These are some problems in Precalculus, Onramps, for compound interest. And here are the general formulas. For n compounds per year, for example, if n is semi-annually, then it would be 2. N is monthly, n is 12. N is quarterly, n is 4. A equals P times 1 plus R over N to the NT power, where N is the number of compounding periods, the number of compounds per year. T is the number of years. R is the interest rate, written as a decimal. So if you're given a number, percent interest rate, you have to divide by 100. P is the principal, and A is the amount that's accumulated. If it's continuously compounded, which the more compounding periods you have, the larger it accumulates to, the better your interest. So compound continuously, A, the amount accumulated, equals the principal times E to the power of RT. Again, where R is the annual percent rate as a decimal, and T is the time. So I'm going to do two questions here, one for some amount of compounds per year and one for continuous. In each one, I will find the amount A of T, the amount accumulated in the account, as a function of the term of the investment. In other words, find the formula, and then determine how much is in the account after 5, 10, and 30 years, and then determine how long it will take for the initial investment. So this says 0.75%. I have to divide that by 100. 0.75 divided by 100 is 0.0075. That's the number. So the accumulated amount equals 500, the principal, times 1 plus the interest rate, 0.0075, divided by the number of compounds. Well, it says monthly, there's 12 months in a year, raised to the 12 t power. Again, it's nt. N is the number of compounds. So then it asks 5, 10, and 30 years. How much accumulates? I'm going to do this on decimals. You can use your TI-84 if you want. Make sure you use the proper parentheses so that nothing gets confused. For example, if I put log 2 divided by 3 in a TI, it might take that as log of 2/3. So you better put log 2 in parentheses divided by 3 so it doesn't get confused. All right, 500 times 1 plus 0.0075 divided by 12 raised to the power of 12t. I'm just going to make a slider for t. And then it asks for 5 years. Here's 5 years. $519.10. It said round to the nearest penny. So that would be 10 cents. 10 years, $538.93. And then if I want 30 years, $626.12. All right, the third part, determine how long it will take for the initial investment to double. So I have to solve this for t. And if it's doubled, A of t equals 1,000. Well, the first thing I will do is divide 1,000 by 500. So 2. If it's doubled, it's 2. Triple will be 3. Quadruple, 4. Equals 1 plus 0.0075 divided by 12 raised to the 12 t power. So how am I going to isolate that t to solve it? Well, I'll take the natural log of both sides. You can actually take any log of any base, but it's traditional to use natural log for these financial, especially when it starts going continuously, because that's log base e, and e is in the formula there, 12t. Now, remember that log of any base of a to the b power equals b times log whatever base of a. So in other words, I can take that exponent and move it in front. So I'm going to take this 12t and move it in front. So this is 12t. Log of 2 equals 12t times log of 1 plus 0.0075 over 12. And now I will just divide everything by 12 times log of 1 plus 0.0075 over 12. So log of 2 divided by 12 times 1 plus 0.0075 divided by 12 is going to equal the time. And it's a simple formula. If you want to know the time to double, it's going to be the natural log of 2 divided by the number of compounding periods times 1 plus the interest rate as a number So if it's given as a percent, divide by 100, divided by the number of compounding periods. And if I do this on Desmos, if you want to know triple, it's log of 3. Log of 2, 12 times. Oops, I forgot the log. How come you didn't tell me this? And even when I said the formula, it's 12, it's the number of compounding periods times the natural log of 1 plus the interest rate written as a number divided by the number of compounding periods. So 12 times natural log of 1 plus 0.0075 over 12. And that equals 92.45 years. It doesn't say what to round it to, so I'm just going to round it to 2 decimal places. All right, so that was with compounding monthly. This one, all of a sudden I wondered if I hit the record button. This one is going to be compound continuously. Remember the continuous formula. A equals P times E to the RT power, where R is the interest rate as a number. If it's given as a percent, divide by 100. T is the time. So the general formula is A of T they want equals the principal, 5,000, times E to the interest rate, 2.125 divided by 100, 0.2125 times T. And then if I want 5, 10, and 30 years, I'm going to do Desmos again. I have 5,000 times E raised to the 0.02125 T. And T is 30. I've already got 30 up there. $9,458.73. If T is 10, $6,183.83. If T is 5, $5,560.50. And so there's, now I want to know how much time it will take to double. So again, this is going to be, to double 5,000 is going to be 10,000. And 10,000 divided by 5,000 is 2, equals E to the 0.02125 T. I want to solve for T. I will take the natural log of both sides. Natural log of 2 equals the natural log of E to the 0.02125 T. Natural log is log base E of E is just 1. They cancel out. So this is log base 2 equals 0.02125 T. And if I divide both sides by that interest rate written as a number, 0.02125, that will tell me the time to double. So for continuous interest, it's the log of whatever it is. If you double 2, triple 3, quadruple 4, 100 times 100, divided by the interest rate written as a number. So I will do this on Desmos. Log of 2 divided by, whoops, somehow I got a slash in there, divided by 0.02125, 32.62 years in this case. So there's 2 different questions, one for some number of periods that's not continuous, in this case it was 12, and one for continuously compounded interest. If you want to see it again, be kind, rewind, and watch it again.